The Great Pyramid of Giza remained the tallest structure on Earth for almost 4,000 years. How did ancient societies, without modern technology, create such wonders? This video uncovers the forgotten resource strategies that made these massive architectural projects possible. You will learn the precise methods civilizations used to organize thousands of people, source millions of stones, and sustain these efforts across generations. We will reveal how they managed supply chains that stretched for miles and coordinated labor forces with an efficiency that can still teach us lessons today. How did they move stones heavier than elephants across deserts, and what kept the workers motivated for a lifetime? By the end, you will understand the hidden blueprints for human collaboration and resilience that built our world. What does it take for a society to build something meant to last forever? These architectural marvels were far more than just big piles of stone. They represented a civilization's ultimate ambition, projects so vast they could consume the entire economic output of a kingdom for generations. Think of the Roman aqueducts, snaking for hundreds of miles across valleys and through mountains to bring fresh water to thriving cities, or the towering ziggurats of Mesopotamia, which functioned as sacred mountains connecting heaven and earth, while also acting as the central hubs for an entire region's administration and grain storage. These were not optional construction jobs, they were the absolute core projects of a society, immense undertakings that reflected the political will, spiritual beliefs, and raw technological confidence of their age. They served as powerful statements, declaring a ruler's authority, a people's devotion, and an engineer's mastery over the natural world. To even propose such a project was to stare directly into a logistical nightmare. How do you feed thousands of workers year after year? Where do you find millions of identical bricks? How do you maintain the will to see through an endeavor that you know you will never live to see completed? The sheer scale of these ambitions sets the stage for the real mystery, the forgotten systems of organization and supply that made the impossible merely a matter of time. The real secret was not just finding hands to work, but hearts and minds willing to commit. Ancient leaders understood that moving mountains of stone required first moving the human spirit. They turned back-breaking toil into a sacred seasonal rhythm. When the Nile River flooded its banks each year, Egyptian farmers found their fields submerged and their usual work paused. Instead of idleness, this became a time of national purpose. Vast crews of these farmers would travel to the pyramid sites, where their labor was framed not as forced servitude, but as a duty to the gods and the pharaoh, a direct contribution to the cosmic order. In return, they were provided with hearty rations of bread and beer, comfortable lodgings, and the elevated social standing that came from participating in a project for the ages. This was not the grim picture of slavery we often assume. It was a highly organized, ritualized system that wove the pyramid's construction directly into the fabric of Egyptian life and its agricultural calendar. The work became a shared communal endeavor, a way to earn honor and secure your family's place in the community while serving a higher calling. This brilliant strategy ensured a motivated, rotating workforce that appeared like clockwork every year without crippling the kingdom's food production. The same fields that fed the nation also, in their downtime, provided the hands that built its most enduring monuments. This reveals a profound insight into the ancient mind. They saw human psychology and social cohesion not as soft concepts, but as tangible, critical resources to be managed as carefully as stone and rope. They built a culture of contribution that could outlast any single lifetime. This same sophisticated understanding of motivation and logistics extended to the very materials they used. These builders were masters of using what the land itself provided. They understood that the greatest resource was often right beneath their feet, and their genius lay in adapting their grand visions to the local landscape. This was not a compromise, it was a core strategy. Consider the Inca Empire constructing its magnificent structures high in the Andes Mountains. They did not haul giant blocks of granite from hundreds of miles away. Instead, they sought out the natural stone of the mountain itself. Their stonemasons would identify quarries along the ridges near a construction site, then use ingenious techniques to split the living rock into perfectly shaped blocks. This approach minimized the immense challenge of transport in such rugged terrain. It also meant their fortresses and temples looked as if they had grown directly from the mountain, a fusion of human artistry and natural geology that has withstood centuries of earthquakes. This principle of local sourcing was a universal rule. When the Romans built their legendary roads and aqueducts across their vast empire, they used local stone, local timber, and local labor. This drastically reduced the logistical complexity and cost of their projects, allowing them to build faster and more efficiently from Britain to North Africa. The entire structure was not built from rare, imported materials. Those were reserved for moments of high symbolism. An Egyptian pharaoh might commission a pair of towering obelisks to be carved from a specific red granite quarry hundreds of miles down the Nile. But these were the exception, the dramatic centerpieces meant to convey divine power and reach. The millions of limestone blocks that form the pyramid's core came from quarries just a short boat ride away. This selective sourcing reveals a remarkably modern and sophisticated understanding of supply chain management. They prioritized efficiency and practicality, investing immense effort only where it would yield the greatest symbolic or structural return. It reminds us that sustainability and resourcefulness are not modern inventions, but ancient wisdom. This practical approach to materials leads directly to an even greater puzzle. Once you have your local stone, your nearby timber, your regional clay, how do you move these colossal weights across rivers, up hills, and through deserts? Moving these multi-ton stones required networks of movement as grand as the monuments themselves. The Egyptians did not just pull blocks on sledges, they turned the desert into a slick pathway. Archaeologists believe they poured water on the sand in front of the heavy wooden sledges, a simple act that dramatically reduced friction and made it possible for teams to move immense weights. This was physics in action, a practical application of knowledge that turned an impossible drag into a manageable task. In other cases, they dug canals directly from the Nile to the construction site, floating stones on barges during the annual flood, letting the river itself do the heavy lifting. They were not fighting their environment, they were collaborating with it, using seasonal rhythms to their absolute advantage. Across the world, the Romans perfected this idea of the path itself as the invention. Their legendary road networks, arrow straight and built to last, were not just for marching legions. They were the supply chains of an empire, enabling the use of specialized carts and wagons that could carry massive loads of stone and timber from regional quarries to distant cities. In the dense jungles of Mesoamerica, the Maya constructed wide, raised causeways known as sacbiob. These white-paved roads cut through impassable terrain, allowing organized processions of workers to transport goods and materials between ceremonial centers, binding their world together with stone pathways. Even across the vast Pacific, the Polynesians demonstrated incredible transport ingenuity. Using their advanced knowledge of the sea and massive outrigger canoes, they transported volcanic stone for monuments across open ocean, a feat of nautical engineering that boggles the mind. The common thread was an intimate, almost conversational relationship with the landscape. Ancient engineers were master readers of their world. they did not simply plot the shortest point from A to B. They studied the lay of the land, the flow of the water, and the turn of the seasons. They asked, where is the ground the firmest? When does the river run highest? Which way does the wind blow? By answering these questions, they optimized their routes and timing, turning potential obstacles like a muddy plain or a seasonal stream into integral parts of their logistical plan. This was not brute force, it was brilliant finesse. This deep environmental knowledge allowed for innovation that was both low-tech and breathtakingly effective. But moving the stone was only half the battle. The true magic, the force that brought these projects to life, was the human engine itself, a story of organization and spirit we will uncover next. The true engine behind these projects was a workforce that appeared and receded like the tides. This was not a permanent army of laborers, but a seasonal pulse of human energy perfectly synchronized with the rhythms of the land. In ancient China, the massive task of building and maintaining the Great Wall was a seasonal duty for countless farmers. When the harvest was in and the fields were fallow, these men would travel to the frontier. They traded their plows for tools, contributing their labor as a form of tax or civic duty, often receiving food, salt, or cloth in return. This system was a brilliant balancing act. It prevented the agricultural heartland from being stripped of its essential workers during planting or harvest, ensuring the kingdom itself remained fed and stable. At the same time, it provided a vast, renewable labor force for a project that stretched across centuries. The wall was not built in a single frantic push, but through the accumulated effort of countless seasonal cycles, each one adding another layer of stone. This cyclical approach reveals a mindset that thought in generations, not just years. Leaders accepted that progress would be incremental, that a project might only advance a few feet in a single season. The immediate gratification of rapid completion was willingly sacrificed for the long-term stability of the society itself. This patient, sustainable model prevented the kind of labor exhaustion that could topple empires. It was a social contract written in stone and sweat, one that supported both the grand ambition and the humble farmer. This intricate dance between human labor and natural cycles required a conductor, a central intelligence capable of organizing thousands of people across vast distances. The silent, steady pulse of labor was guided by an unseen hand, a meticulous mind that tracked every loaf of bread, every copper chisel, and every block of stone. This was the fifth forgotten strategy, the power of a centralized bureaucracy. While armies of workers moved mountains, armies of scribes tracked every pebble. In ancient Mesopotamia, the true foundation of a ziggurat was not just sun-dried brick, but the thousands of clay tablets that recorded its construction. These detailed administrative documents listed precise allocations of barley for the workers, quantities of bitumen for mortar, and shipments of timber from distant forests. This was an early, highly effective form of project management, a system designed to anticipate shortages before they could cripple the entire endeavor. The Roman Empire perfected this approach, employing a legion of clerks and surveyors who produced endless scrolls of accounts. They tracked expenditures, measured progress against timelines, and maintained accountability across thousands of miles. This bureaucratic infrastructure was the nervous system of the empire, allowing a single administrator in Rome to understand the resource status of a bridge being built in Gaul or an aqueduct in North Africa. Without the twin innovations of writing and standardized numerical systems, such coordination would have been utterly impossible. It underscores a profound truth that administrative genius was just as critical as engineering brilliance. These ancient records, often seen as dry lists, are actually treasure maps to a forgotten way of thinking. They reveal the meticulous, strategic minds that could balance 1,000 variables at once, ensuring that human ambition never outpaced its logistical support. This intricate system of accounting and control, however, required a constant and massive flow of capital to keep it running. The question then becomes, what economic engine produced the wealth to pay for all of this, from the scribe's stipend to the farmer's ration? The wealth to build forever did not simply exist. It had to be systematically gathered from every corner of a kingdom. This sixth forgotten strategy was the art of economic mobilization, a circulatory system of tribute, tax, and trade that turned scattered resources into concentrated power. Think of the vast Persian Empire, a mosaic of conquered lands stretching from Egypt to India. Each province was required to send an annual tribute to the imperial center, a payment not just in gold and silver, but in the very materials of construction, timber, precious metals, and skilled craftsmen. This constant flow of wealth from the edges to the core funded monumental infrastructure like the Royal Road, a highway over 1,500 miles long that bound the empire together and allowed for the rapid movement of troops, information, and of course, more resources. This was not mere plunder, it was a sophisticated system of redistribution. The wealth collected was then used to pay architects, feed laborers, and purchase materials, effectively creating a circular economy where resources from the provinces returned to them in the form of grand public works that reinforced imperial authority. In pharaonic Egypt, the system was even more direct. The state collected taxes not just in grain, but in the labor of its people. This was the corvée system, where every citizen owed a certain number of days of work to the state each year, a duty often fulfilled on the pyramids, the temples, or the canals. This labor tax was the engine that built civilization itself. It centralized the collective effort of an entire society, transforming individual obligation into national monuments. The farmer who paid his tax by hauling stone for a season was not just a laborer, he was an investor in the kingdom's eternal legacy. This economic model created a self-sustaining cycle. The state collected grain as tax, stored it in massive granaries, and then distributed it as rations to the very workers who were building the state's projects. The workers, fed and housed, continued their labor, which in turn strengthened the state's power and its ability to collect more taxes. It was a feedback loop of creation, where wealth was not hoarded but actively put to work, providing employment, stability, and a shared sense of purpose. This intricate dance of resource management reveals that ancient economies were far from primitive. They understood how to channel the productive capacity of an entire society toward a single, unifying goal. The stone was paid for, the labor was compensated, and the entire monumental effort was underpinned by a complex and deliberate financial architecture. This foundation of centralized wealth and meticulous organization ultimately provided the stable platform required for the next critical element, the spark of technological innovation that pushed the boundaries of the possible. The ingenuity of ancient engineering lies not in complex gadgets, but in the masterful application of simple principles. These builders understood the fundamental physics of levers, pulleys, and inclined planes, transforming backbreaking labor into a manageable, almost elegant process. In Greece, the construction of soaring marble temples was made possible by wooden cranes and winches, devices that multiplied human strength and allowed workers to lift massive blocks into position with a level of control that pure muscle could never achieve. Far to the east, Chinese engineers developed sophisticated counterweight systems for installing immense city gates, using balanced weights to swing monumental timbers into place with minimal effort. This was not about inventing the new, but about perfecting the known, creating reliable tools that could be operated by many and repaired by all. This philosophy extended to the very fabric of their structures. Look at the breathtaking terraces of Machu Picchu, where Inca stonemasons carved granite blocks to fit together with such precision that not even a blade of grass can slip between them. This technique of interlocking masonry created immense stability without a single drop of mortar, allowing the entire structure to shift and settle during earthquakes without collapsing. It was a system designed for permanence and resilience. The overarching principle was a clear preference for reliability over dazzling complexity. A simple rope and pulley could be fixed on site with local materials. A broken counterweight could be recarved from a nearby tree. These were scalable, maintainable solutions that ensured a project in a remote province could be built with the same effectiveness as one in the capital city. This accumulated engineering wisdom was far too valuable to be written down in manuals. It was a living knowledge passed carefully from one generation of artisans to the next through the intimate, hands-on tradition of the apprenticeship. The most sophisticated crane or the most detailed blueprint is useless without the skilled hands to wield it. The true lifeblood of these projects flowed not through rivers or roads, but through the minds of master craftsmen. The eighth forgotten strategy was a living library of knowledge, meticulously passed from one generation to the next through guilds, apprenticeships, and sacred texts. In medieval Europe, the great cathedrals rose skyward thanks to the secretive Mason guilds. These were not mere labor unions, but custodians of architectural wisdom. They guarded their techniques for cutting stone, their complex geometry for vaulted ceilings, and their recipes for durable mortar as closely as a state secret. A young apprentice would spend years, even decades, learning the trade from the ground up, starting with simple tasks like mixing mortar or hauling rubble before ever being trusted with a chisel. This was a system of gradual, total immersion, ensuring that every nuance of the craft was absorbed through direct experience. The master's knowledge was not written in a book, but embedded in his hands, and he transferred it slowly, carefully, to his chosen successor. This created an unbroken chain of expertise that could span centuries, allowing each new generation to build upon the successes and learn from the failures of the last. Across the world, ancient India formalized this process in the Shilpa Shastras, comprehensive texts that codified everything from the spiritual symbolism of a temple's lay out to the precise mathematical proportions for its pillars. These were not suggestions, they were canonical rules, ensuring that a temple built in the south would embody the same divine principles as one built in the north, even if separated by hundreds of years. This preserved a cultural and technical standard of breathtaking consistency. The knowledge economy was every bit as vital as the economy of grain or stone. Losing a master stonemason without an heir was a catastrophe on par with losing a quarry. This system of continuous learning created a culture of relentless, if gradual, innovation. A carpenter might slightly improve a joint, a smith might perfect a tool's temper, and these tiny, accumulated advances would be passed down, refining methods over generations. This resilient network of human skill was the final, crucial component, the element that tied all the other strategies together into a coherent, sustainable whole. Yet even the most skilled craftsmen, the most organized bureaucracy, and the most robust supply chain still had to contend with a powerful and unpredictable partner, the environment itself. The ancient builders were in constant conversation with the world around them. They understood that the land and sky were not obstacles to be conquered, but partners in a grand collaboration. This ninth forgotten strategy was environmental synchronization, a deep and predictive harmony with natural cycles that turned seasonal patterns into a powerful engine for construction. The Egyptians did not merely wait for the Nile's annual flood, they built their entire construction calendar around it. quarrying operations were timed so that massive stone blocks were ready and waiting at the river's edge just as the floodwaters began to rise. When the river swelled, it transformed the desert into a network of temporary canals, allowing heavy barges to float these colossal stones directly to the base of the pyramid plateaus. The river itself became a liquid highway, and the workers who would normally be farming became the sailors and stevedores for this annual logistical miracle. This was not just efficient, it was elegantly sustainable. It used a natural, recurring event to solve the single greatest challenge of moving immense weight, all while keeping the agricultural workforce productively engaged. A world away, in the arid landscapes of the American Southwest, the ancestral Pueblones, sometimes called the Anasazi, demonstrated a similar foresight. They constructed their intricate cliff dwellings and great houses in precise relation to the scarce water. They engineered elaborate systems of check dams and cisterns to capture every precious drop of seasonal rainfall, channeling it to terraced gardens and reservoirs. Their settlements were not placed at random, but were positioned after generations of observing where water would flow and collect. They were forecasting their most critical resource, planning their community's growth around the predictable, if limited, bounty of the desert storms. This profound synchronization reveals a mindset that saw time as a cyclical partner. These cultures planned not in rigid, linear years, but in flowing cycles of flood and drought, rain and sun. By forecasting these resource flows, they could undertake projects that spanned decades without ever risking the exhaustion of their environment. They minimized energy expenditure by letting nature do the work, and they reduced the risk of catastrophic shortages by aligning their ambitions with the Earth's own rhythms. This was a form of long-term ecological intelligence that we are only now relearning. Such a seamless integration with the environment, however, could only be sustained by a society that was itself deeply integrated, bound together by shared beliefs and a common purpose that transcended the work of any single season. A monument's true strength was often measured not in stone, but in its power to unite. These vast architectural projects served as a profound form of social engineering, transforming diverse groups of people into a single, cohesive community with a shared identity. In ancient Athens, the Parthenon was far more than a temple to the goddess Athena. It was a bold declaration of Greek cultural and political unity, a symbol of collective pride paid for by the collective treasury of the Delian League. Every citizen, whether they were a sculptor, a sailor, or a farmer, could look upon that luminous marble structure on the Acropolis and see a reflection of their own civilization's highest ideals. It was a physical anchor for their shared identity, a constant reminder of what they were building together. Similarly, the Great Wall of China was not just a barrier against northern armies. For the millions who worked on it, it became a symbol of a shared defensive frontier, a project that defined the very boundaries of their civilization and gave everyone from every province a common cause. By actively involving communities in the construction process, leaders brilliantly channeled energies that might have otherwise turned to internal conflict. Potential dissent was redirected into collective achievement. A person who had spent a season hauling stones for a city wall was far less likely to challenge the authority that built it. They had a personal, physical stake in its existence. This fostered deep loyalty and long-term public support because people could literally see themselves in the structures rising around them. The psychological resource of shared purpose was every bit as critical as quarried limestone or sturdy timber. It was the invisible mortar that held the entire endeavor together. This understanding reveals the final, brilliant dimension of ancient strategy. They knew that to build something eternal, you first had to build a society that believed in it. This intricate web of social cohesion, however, was often woven across vast distances by another powerful force, the constant flowing exchange of trade. Even the most self-sufficient societies reached across continents to acquire the final touches of greatness. While local stone and timber formed the bones of their structures, ancient builders turned to vast trade networks to supply the lifeblood of prestige and permanence, specialty materials like metals, rare woods, and precious stones. The legendary cedars of Lebanon, tall and resistant to rot, were not just local trees for the Phoenicians, they were a global commodity. Phoenician merchants shipped this prized timber across the entire Mediterranean, where it became the sacred beams in Egyptian temples and the majestic gates of Mesopotamian palaces. This was not simple barter, it was a sophisticated, long-distance supply chain operating centuries before the modern era. Far to the east, the sprawling Silk Road was more than a route for silks and spices. It was a conduit for architectural innovation, where knowledge of Roman concrete, Central Asian arch designs, and Chinese ironworking techniques traveled alongside caravans, cross-pollinating building methods across entire civilizations. These trade relationships delivered more than physical objects, they transmitted ideas. A Mesopotamian architect might see a new type of bronze clamp used to join stones, a technique he could then adapt for his own ziggurat. A Chinese engineer might learn of a superior mortar recipe from a Persian trader. This constant flow of information enriched architectural styles, creating a shared vocabulary of design that stretched from the Atlantic to the Pacific. By intentionally weaving global commerce into their grand plans, civilizations achieved a crucial form of supply chain diversification. They were not putting all their eggs in one local basket. If a regional quarry failed or a local forest was depleted, they could turn to their trade partners to source an alternative. This strategic sourcing allowed them to incorporate materials with unique properties, like exceptionally hard stones for foundations or corrosion-resistant metals for critical joints, directly enhancing both the grandeur and the incredible durability of their monuments. This ancient globalization meant that a single building could tell a story of ecological, cultural, and commercial connections spanning thousands of miles. The final genius in this entire process, however, was often found in the way these diverse materials were assembled, through a principle of breathtaking simplicity, modular design. The final brilliant layer of ancient strategy was a simple one: build everything from a set of standardized, repeating parts. To manage the overwhelming complexity of a massive temple or an entire city, cultures from Rome to Cambodia turned to modular design. The Roman approach was one of breathtaking practicality. They manufactured bricks and concrete blocks in standard sizes, creating a universal construction kit for their empire. This meant a unit of soldiers stationed in Britain with only basic training could build a fortress as strong and as quickly as a veteran legion in Italy. The stones fit together the same way every time. This standardization drastically reduced the need for highly specialized stonemasons on every single site, accelerating construction to an unprecedented pace and simplifying repairs for centuries to come. In the jungles of Southeast Asia, the builders of Angkor Wat applied a similar principle, not to bricks but to geometry itself. The entire sprawling temple complex is a symphony of repeating squares and concentric rectangles. This repetitive pattern simplified the immense task of planning, allowing architects to design a small, perfect module and then replicate it across a vast area, creating a sense of immense scale and cosmic order from a single, elegant blueprint. This modular thinking enabled a form of ancient prefabrication. Columns, archways, and even intricate carvings could be produced by specialized workshops far from the noisy, dusty construction site. These finished components were then transported and assembled on location, slotting together with the satisfying click of a solved puzzle. This method minimized waste, as every piece was designed for a specific, repeating role, and it made training new workers remarkably straightforward. A laborer only needed to learn a few repetitive tasks to become a productive part of the grand machine. This was the ultimate expression of efficiency, a way to conquer the chaos of a massive project by breaking it down into countless, identical, and manageable steps. Such organizational genius, however, was not just about building new things from scratch, but also about the wisdom of giving old materials and structures a powerful second life. Ancient builders saw the past not as ruins, but as a quarry of both stone and story. Across the ancient world, the act of recycling was a profound strategy, a way to weave history directly into the foundations of the new. The Romans were perhaps the most pragmatic masters of this art. When they conquered a city, they did not merely leave its buildings to crumble. They systematically dismantled them, transporting the very stones of a defeated rival's walls to be integrated into a new forum or temple in Rome itself. This was a brilliant double gesture, a practical solution that saved immense labor and resources, while simultaneously erasing the physical memory of an enemy and proclaiming Roman dominance. The stone itself became a trophy, its previous life adding a layer of psychological power to its new function. This principle of adaptive reuse was a global phenomenon. In ancient Egypt, pharaohs would often dismantle older, lesser monuments to build their own, carefully carving their names into the recycled blocks. In doing so, they were not just saving effort, they were consciously linking their reign to the legitimacy and sacred power of their predecessors, building a continuous lineage in stone. This practice created a circular economy long before the term existed. Materials were valued not for their newness, but for their durability and their accumulated history. A single block of granite might serve in 3 different temples over 1,000 years, its journey a silent testament to shifting beliefs and powers. This minimized environmental impact, reducing the constant demand for fresh quarrying and the associated toll on the landscape. It was a sustainable mindset born of necessity and deep respect for the material world, a recognition that resources were finite and should be honored across generations. This ancient wisdom of valuing the old to build the new reveals a culture that saw itself as part of a long, unbroken chain. And this chain was held together by something more powerful than mortar. It was bound by the invisible forces of shared ritual and deeply held belief, which directed the flow of every resource toward a sacred purpose. The very act of building was often a sacred offering in itself. Across the ancient world, the immense cost of a monument was not seen as an expense, but as an essential investment in the cosmic order. This ritual economy transformed stone and labor into acts of devotion, channeling a society's entire productive capacity toward the divine. In Mesoamerica, the towering pyramids that rose from the jungle were not just temples, they were physical prayers. A community might dedicate its finest jade, its most brilliant feathers, and the labor of its people to the construction, viewing these offerings as absolutely necessary to maintain the favor of the gods and ensure the sun would rise again. This belief system created a powerful, self-justifying cycle. The more a society invested in its sacred structures, the more it demonstrated its piety, and the more it believed in its own security and prosperity. This was not a simple transaction. It was a deep cosmological partnership where architecture served as the meeting point between humanity and the gods. By framing the entire endeavor as a spiritual duty, leaders could mobilize resources on a scale that would be unthinkable for a purely secular project. A farmer might willingly contribute a portion of his harvest or a season of his labor, not because he was forced, but because he genuinely believed his contribution helped hold his world together. This fusion of faith and logistics provided a profound motivation that transcended personal gain. It turned the quarryman, the carver, and the porter into essential participants in a grand divine plan, granting their work a meaning that echoed into eternity. This intricate system ensured that the greatest architectural treasures were often those built not for a king's vanity, but for a people's collective soul. The immense effort was justified by a shared belief that their survival, their reigns, their very reality depended on it. This spiritual framework for organizing society and its resources reveals a fundamental truth that the most enduring structures were often those built upon the strongest foundations of belief. And just as faith could organize a people, so too could the disciplined structure of an army. A standing army is a massive, organized force of disciplined individuals, and ancient empires quickly realized its potential extended far beyond the battlefield. During long periods of peace, these legions became one of history's most effective construction crews. The Roman military machine, for instance, was not just a fighting force, it was a mobile, self-sufficient engineering corps. When not engaged in conflict, legions would build the very infrastructure that held the empire together, from the iconic, arrow-straight roads that accelerated the movement of troops and trade, to the sturdy bridges that spanned wide rivers and the frontier forts that secured new territories. This was a dual-use strategy of brilliant efficiency. It kept thousands of highly disciplined soldiers productively occupied, preventing idleness and maintaining their skills in organization, teamwork, and rapid execution. Simultaneously, it accelerated the development of civic infrastructure at a pace civilian labor alone could never match. The engineering specialists within these legions developed standardized, incredibly durable techniques for construction under all conditions, whether in the frozen north or the arid deserts of Africa. A legionary was as adept with a surveying tool and a trowel as he was with a sword and shield. This military-civilian synergy was a powerful tool for imperial consolidation. A newly conquered region would quickly be integrated not just by the presence of soldiers, but by the tangible benefits they built, the roads that connected isolated villages to bustling markets, and the aqueducts that brought fresh water to growing towns. It demonstrated how a state could repurpose its most powerful existing institution, the army, to serve multiple overlapping goals of defense, development, and control. This seamless interplay between securing territory and improving it leads directly to one of the most critical of all ancient resource strategies, the mastery of that most essential element, water. Water was the silent blueprint behind the grandest of ancient plans. Before a single foundation stone was laid, the most critical question was often not where to build, but where the water would flow. The great cities of the Indus Valley, like Mohenjo-Daro, were not merely collections of homes, they were masterpieces of hydraulic engineering. Their streets were laid out on a precise grid, all serviced by a complex, covered drainage system that channeled wastewater away from public spaces, a level of urban planning that would not be seen again for millennia. This was not a luxury, it was the foundation of public health and social order, enabling a dense urban population to thrive. Similarly, the Nabateans carved their magnificent city of Petra from rose-red cliffs in the heart of a desert. Their genius was not just in carving rock, but in capturing every fleeting drop of rain. They engineered a vast network of channels, dams, and cisterns that harvested seasonal downpours, storing millions of gallons of water to sustain the thousands of workers and artisans who built the city's iconic tombs and temples. This mastery over a scarce resource transformed an arid canyon into a flourishing capital. On the construction site itself, water was the ultimate multi-purpose tool. It was mixed with gypsum or lime to create the strong mortar that locked walls together. It was poured onto sand to create slick pathways for moving colossal statues on wooden sledges. It was channeled through temporary canals to float heavy stones right to the building site. And of course, it was essential for keeping the vast labor force hydrated and healthy under the relentless sun. Securing a predictable, abundant water source was always the first major investment, the prerequisite that made every other ambition possible. This holistic control of water exemplifies a profound truth. These projects were not just built on land, they were built upon a deep, predictive understanding of the natural world. And this understanding extended beyond the earth, reaching for the rhythms of the sky itself. The timing of their greatest efforts was often written in the stars. The movement of the sun and stars was a clockwork that these cultures learned to read with astonishing precision. Long before the first stone was set for a monument like Stonehenge, its architects were observing the heavens, noting the exact point on the horizon where the sun would rise on the longest day of the year. This was not merely for ceremony. That precise alignment created a natural deadline, a celestial trigger for action. It signaled a time when scattered communities, their own seasonal planting and harvesting complete, could converge on the sacred site. The summer solstice became a logistical pivot point, drawing in a temporary labor force that would spend the following weeks hauling and raising the massive sarsen stones, their work framed by the cosmic event itself. In Egypt, the annual reappearance of the star Sirius just before dawn held even greater practical weight. Its heliacal rising coincided perfectly with the coming of the Nile flood, the event that dictated the entire Egyptian year. This celestial signal told farmers their fields would soon be underwater, and it told the state that the national workforce was now available, and the river was ready to become a highway for moving stone. The temple's alignment to specific stars was a permanent stone calendar, ensuring that the rhythm of construction never fell out of sync with the rhythm of the land. This was resource management on a grand temporal scale. By letting the cosmos set the schedule, planners optimized everything. They avoided the winter rains that could turn quarry roads to mud. They harnessed the long days of summer for maximum work hours, and they seamlessly integrated the ebb and flow of a seasonal labor pool into a project spanning generations. The sky was their ultimate project manager, its predictable cycles providing a stable, unchanging framework within which human ambition could unfold. This celestial choreography extended down from the stars to include the raw, earthy power of the animals that lived and worked alongside humanity. The strength of 100 men could be found in a single creature. Ancient builders understood this, turning to the immense power of domesticated animals to multiply their own efforts on a scale that defied human limitation. In the vast construction yards of South Asia, the elephant was not merely an animal, it was a living, breathing piece of engineering equipment. Trained from a young age, these intelligent giants could push, pull, and lift colossal stone blocks with a precision that teams of workers could never match. They moved obelisks that weighed more than a small house, carefully positioning them into place with their sensitive trunks and incredible strength. This was not brute force, it was a sophisticated partnership built on trust and generations of accumulated knowledge about animal behavior. Across the trade routes of Eurasia and the deserts of the Middle East, the dependable ox was the engine of empire. Hitched to heavy wooden carts, these patient animals could haul tons of quarried stone or timber across distances that would exhaust a human porter, maintaining a steady, relentless pace that kept supply lines flowing. The camel, perfectly adapted to arid environments, became the ship of the desert, carrying vital materials across seas of sand where no wheeled cart could travel. Domesticating these species specifically for labor was a monumental investment in itself, requiring entire support systems of dedicated handlers, veterinarians, and vast pastures for grazing. This created a renewable, self-sustaining energy source. An ox could work for years, and its offspring could continue that work for generations, a living inheritance of power that made long-term projects feasible. This integration of fauna into the construction process reveals a holistic worldview, one that saw the entire natural world, from the strength of an elephant to the endurance of an ox, as a toolkit to be respectfully and intelligently employed. This powerful collaboration between human, animal, and machine, however, required a stage upon which to perform, a network of temporary workspaces that appeared and vanished as the project progressed. These sprawling projects generated their own temporary cities, bustling hubs of life that appeared almost overnight in the shadow of the rising monument. The pyramid builders did not commute from distant homes. They lived in carefully planned villages erected just for them. These were not squalid camps, but organized communities complete with long, mud brick barracks, large communal bakeries producing thousands of loaves daily, and even facilities where medical care was provided for injuries and common ailments. Every aspect of these settlements was designed for one purpose: to sustain the human engine of construction over decades. The layout itself was a masterpiece of logistical foresight. Wide, straight streets allowed for the unimpeded flow of ox carts carrying stone from the nearby quarry, while smaller paths connected living quarters to the workshops and kitchens, minimizing wasted time and movement. This was urban planning in its most pragmatic form, a city built for workflow. When the final capstone was set and the workers dispersed, these settlements were often simply abandoned to the desert winds, their materials slowly returning to the earth. This transient footprint meant that the immense environmental impact of housing and feeding thousands of people was concentrated only for the duration of the build, leaving the surrounding landscape to recover. This strategy of the mobile, temporary city provided incredible flexibility, allowing a civilization to focus its entire productive might on a single, remote point on the map without the long-term burden of maintaining a permanent town there. It was a brilliant answer to a fundamental challenge: how do you concentrate vast human power without causing permanent disruption? Such massive, high-stakes operations, however, required more than just efficient housing. They demanded a clear plan for when things went wrong. These ancient builders never put all their eggs in one basket. They understood that a project spanning generations could not be left vulnerable to a single bad harvest or a collapsed quarry. Their solution was a 20th strategy, a profound understanding of risk mitigation through deliberate redundancy and strategic storage. Think of the massive state granaries erected near every major construction site in ancient Egypt. These were not simple sheds, they were vast, sealed silos filled with surplus grain, a buffer against years of drought or poor Nile floods. This ensured that the thousands of workers, the very engine of the project, would be fed and motivated even when the surrounding farms struggled. A hungry workforce is a slow, disheartened one, and the ancient planners knew that morale was as critical a resource as limestone. This same principle of surplus extended to the materials themselves. Stockpiles of dressed stone, carefully cut timber, and reserves of specialized tools were maintained at the site. If a shipment from a distant quarry was delayed by a storm or a landslide, the work did not grind to a halt. The builders simply dipped into their reserves, maintaining the project's relentless momentum. This was not hoarding, it was a calculated investment in continuity. In some cases, this redundancy was built directly into the supply chain. A pharaoh might commission 2 or 3 quarries for the same type of stone, located in different regions. If political unrest or natural disaster closed one down, the others could pick up the slack. Multiple transport routes, both river and land, were developed for critical materials, ensuring that no single point of failure could strangle the entire endeavor. This reveals a mindset that was deeply risk-aware, one that accepted uncertainty and planned for it with cold, practical logic. They were playing a long game, and they built shock absorbers into every step of the process. This prudence, this willingness to invest heavily in safety nets, is what separated a project that was merely ambitious from one that truly stood the test of time. It was a form of ancient project management that understood the true cost of a delay was not just time, but the fragile will of a generation. This practical wisdom, however, was always supported by a deeper, more powerful force, the cultural stories that gave meaning to the entire monumental effort. A story could lend a strength to stone that no mortar could ever provide. Across countless cultures, the most powerful resource for sustaining a project was a compelling narrative, one that wove the very act of building into the fabric of creation itself. At Angkor Wat, the sprawling temple complex was not merely a king's tribute. It was designed as a physical model of the Hindu universe, with its central towers representing the mythical Mount Meru, the axis of the world. To haul a stone for its walls was to help hold up the cosmos. In the cold north, Norse sagas told of mighty walls built not by men, but by a giant who demanded the sun and moon as payment, a tale that transformed the awe-inspiring ruins dotting the landscape into the work of primordial beings. These were not just fanciful tales for entertainment. They were strategic tools of immense psychological power. By embedding a construction project within a divine mandate or a creation myth, leaders transformed exhausting, mundane labor into a sacred privilege. The worker with a chisel was no longer just a laborer. He was an active participant in a story that would outlive him, a collaborator with gods and heroes. This mythological framing provided an unshakable justification for the immense cost and effort. Why should a society pour its wealth into a mountain of stone? Because the gods commanded it, because the cosmic order depended on it. This shared belief created a cultural momentum that could survive the death of a king or the rise of a new dynasty. The project itself became a national heirloom, its purpose sanctified by tradition. Ritual celebrations held at key milestones, like the laying of a cornerstone or the raising of a final column, were not mere parties. They were powerful reinforcements of this shared identity, moments where the entire community could see and feel their collective progress toward a divine goal. This reveals the ultimate intangible resource, a unifying ideology that could fuel a project for centuries. The most durable monuments were always those built upon the strongest foundations of belief. Yet even the most powerful story had to contend with the physical realities of the world, the unyielding forces of climate and geography that shaped every ancient plan. The most resilient structures were often those that seemed to grow directly from the earth itself. Ancient architects possessed a deep understanding that fighting the local geography or climate was a battle they could not win, so they chose instead to collaborate. They observed how the land naturally shed water, how the sun tracked across the sky in different seasons, and how the winds consistently blew. Then, they designed their buildings to work in concert with these forces, a strategy that dramatically reduced the need for imported materials and complex engineering. High in the American Southwest, the ancestral Pueblones constructed their magnificent cliff dwellings within vast, sheltered alcoves. These natural overhangs provided a ready-made roof, protecting the structures from sun and rain, while the thick stone walls of the canyon itself offered superb insulation, keeping the homes cool in the scorching summers and remarkably warm during cold desert nights. This design also provided a powerful form of natural defense, integrating security directly into the landscape. Across the world, in the arid regions of ancient Persia, architects faced a different challenge: the intense baking heat. Their brilliant solution was the wind catcher or badir, a tower that rose above buildings to catch the slightest breeze and funnel it down into the living spaces below. This simple, elegant structure created a natural ventilation system that cooled interiors without consuming a single resource, a masterpiece of passive climate control that required no energy beyond the wind itself. By thinking this way, builders minimized the most costly aspects of construction, the need for massive excavation, long-distance transport of foreign materials, and complex mechanical systems. They were practicing a form of biomimicry, learning from and emulating the efficiency of the natural world. A structure built into a hillside required far less material than a free-standing one, and a building oriented to capture the winter sun and block the summer sun needed less fuel and offered more comfort. This was not a primitive compromise, it was a sophisticated philosophy of harmony. It recognized that the most sustainable resource was the intelligent use of the local environment itself. This principle of adaptation created buildings that were inherently resilient, needing minimal maintenance and enduring for centuries because they were never in conflict with the world around them. This profound intelligence, however, was not the product of a single mind or a homogeneous group. It drew upon the diverse experiences and skills of an entire society, including a segment of the population whose contributions have often been overlooked. The workforce that built the ancient world was a mosaic of every available hand. For decades, we pictured these monumental sites being raised by armies of young men, but the bones and tools left behind tell a different, more inclusive story. Archaeological excavations at sites across the pre-Columbian Americas reveal that women were not only present, but were actively involved in construction and craft production, shaping the adobe bricks and plaster that formed vast city complexes. In ancient Mesopotamia, cuneiform tablets record the activities of entire families dedicated to the seasonal craft of brick making, with each member, from the eldest to the youngest, contributing to the collective output. This was not a society that could afford to leave half its potential untapped. By integrating the efforts of women, children, and elders, ancient planners achieved two crucial goals. They maximized the total available labor force, turning a family unit into a self-contained production team, and they distributed the economic rewards of these state projects, such as food rations and social standing, throughout the entire community. This fostered a profound sense of collective ownership. When a project benefits your entire household, your commitment to its success becomes personal. This nuanced strategy reveals a sophisticated understanding of social economics. It challenges our modern assumptions that ancient labor was brutally segregated, showing instead a pragmatic system that leveraged every skill set to achieve a common goal. The legacy of these collaborative efforts is written not just in the stones they left behind, but in the enduring power they continue to hold over us. The true cost of a cathedral was measured not in gold, but in generations. Across medieval Europe, the master mason who laid the foundation stones knew with absolute certainty that he would never walk through the finished nave, never see the stained glass windows catch the light, and never hear the choir sing in the vaulted space he helped to create. His work was an act of faith in a future he would never see. This intergenerational perspective was the bedrock of legacy building. It required a radical form of patience, a cultural agreement that the most worthy endeavors were those that transcended any single human life. To make this possible, societies created incredibly stable institutions, like the monastic orders that guarded architectural plans and financial records for centuries. Knowledge was not hoarded by a single genius, but carefully passed down through guilds and apprenticeships, ensuring that the vision for a soaring spire remained intact even as the original architect passed from memory. This was not just construction, it was a form of cultural stewardship, where each generation saw itself as a temporary guardian of a sacred project, responsible for handing it off in better shape to the next. They were planting trees under whose shade they knew they would never sit. This profound sense of responsibility demanded more than just architectural skill. It required a robust system of economic incentives to keep the human engine running smoothly across the centuries. A stonecutter's skill could earn his family freedom from taxation for life. Across the ancient world, the most successful projects understood that a worker with a personal stake in the outcome would always outperform one who was merely compelled. This 25th strategy transformed backbreaking labor into a legitimate pathway for social advancement, creating powerful economic incentives that went far beyond daily rations. In ancient China, a farmer conscripted to work on the endless stretches of the Great Wall could earn much more than his keep. Exceptional service or demonstrated skill in engineering might secure him a coveted military promotion, lifting his entire family's status, or grant them precious exemptions from the heavy grain taxes that burdened their village. This was not just payment, it was an investment in one's future and legacy. Similarly, a Roman legionary knew that after 25 years of military service, which included building the empire's roads and forts, his reward was not just a ceremonial medal. He would receive a generous grant of land in a newly pacified territory, a tangible piece of the very stability he had helped to construct. This promise of a farm and the status of a veteran citizen turned the army into a powerful engine of social mobility, attracting voluntary recruits from across the empire. These systems were brilliantly pragmatic. By offering wages, land, or privileges, leaders could attract a voluntary, motivated workforce, drastically reducing the social friction and constant supervision required by forced labor. A man working to secure a better life for his children will innovate, he will care about the quality of his work, and he will endure hardship with a sense of purpose. This alignment of individual ambition with colossal state projects created a powerful synergy. The worker advanced his own station, while the civilization advanced its most enduring monuments. This clever use of non-material rewards, status, and security to achieve immense material ends was perhaps one of the most sophisticated resource strategies of all. It channeled the universal human desire for a better future directly into the stone and mortar of the ancient world. Yet, despite the resilience of these systems, the strategies that built the pyramids did not last forever. A slow unraveling began as the very foundations that supported these monumental endeavors started to fracture and fade. Even the most resilient systems carried a hidden fragility. The intricate networks of supply and labor that built wonders were surprisingly vulnerable, their decline often written in the slow, silent language of environmental strain. The sprawling cities of the classic Maya, for instance, stand as a haunting example. Their grand plazas and towering pyramids required immense quantities of limestone and vast amounts of timber for the burning of plaster. Over generations, the surrounding forests were steadily cleared, leading to soil erosion and a decline in the very agricultural productivity needed to feed the urban populations that built them. This was not a sudden catastrophe, but a creeping exhaustion, where the very act of construction gradually undermined the ecological foundation that made it possible. Their great projects may have contributed to a tipping point where a period of prolonged drought, something a more resilient environment might have weathered, instead led to social unrest and a slow abandonment of their magnificent stone cities. This pattern was not unique. Across the ancient world, the stability required for generational projects was a delicate flower. An empire could fragment from internal political strife, severing the trade routes that supplied specialty materials. A prolonged shift in climate could alter the seasonal floods that were the lifeblood of both agriculture and transportation, rendering entire logistical models obsolete. Economic collapse could empty the state granaries that fed the workforce, halting construction not with a bang, but with the quiet departure of hungry laborers. These declines serve as powerful cautionary tales, reminding us that no system, no matter how brilliantly conceived, is immune to external shocks. The ambition to build for eternity must be tempered by a profound respect for ecological and social limits. The true lesson is not just in their success, but in their quiet ends, a testament to the constant need for adaptation and balance in the face of a changing world. These forgotten blueprints reveal a civilization's true strength lies not in its monuments, but in the wisdom of its systems. The ancient masters understood that moving mountains of stone required first moving the human heart, then aligning its rhythm with the pulse of the land and the flow of the seasons. Their success was a symphony of collaboration, not a solo of brute force. They saw the farmer not as a pair of hands to be commanded, but as a partner in a sacred, seasonal cycle. They perceived the local landscape not as an obstacle, but as a willing collaborator, offering its stone, its timber, and even its winds and waters. They planned not for a single lifetime, but for a legacy that would outlast dynasties, building a culture of contribution where every individual could see their own future reflected in the rising stone. This intricate tapestry wove together the threads of ritual and ration, of trade routes and celestial cycles, of economic incentive and spiritual belief. It was a holistic vision that saw every resource, whether human, natural, or economic, as part of a single, interconnected web. The true lesson for our modern world, with its own colossal ambitions, is this profound sense of integration. We are challenged to look beyond the sheer power of our technology and remember the ancient wisdom of working with our environment, of valuing long-term stability over short-term speed, and of building societies where people are motivated by a shared purpose that transcends their own lifespan. Their legacy asks us a simple, powerful question. As we shape our own world with projects of staggering scale, are we building with the same foresight, the same respect for limits, and the same deep understanding of what truly motivates the human spirit? Which of these ancient strategies, from seasonal labor to intergenerational patience, resonates most with the challenges you see in our world today? Let us know your thoughts in the comments and subscribe for more journeys into the mysteries of our past.